Good morning. Happy that you're here for my talk. I called it Opportunities and Pitfalls of Event-Driven Utopia. That's probably a strange title here. What did motivate me to do this talk, actually? So what I saw over the last couple of years, and basically especially the last year, is that more and more people, more and more companies, more and more of our customers as well are picking up event-driven architectures. It's not a new topic. I mean, there is a book even called Event-Driven Architectures, which is quite old, but I really see that adopted more and more. There's one evidence where you can also see that. So we are at QCon, so you probably also read InfoQ. They did that architecture trends report, for example, and they're in 2018, so that's the graph from 2018, they had event-driven architectures for the early adopters, and already in 2019 in Q1, they moved that basically to the early maturity. So that's just one indication for what I also see in the market, that event-driven architectures are picked up much more and more nowadays. At the same time, we're basically seeing that we don't have yet a common understanding of what event-driven architecture basically means. And this is a good blog post actually by Martin Fowler. He also did a keynote on that. I think it was at the Go to Chicago, which is on YouTube, so you can watch that as well. And he said, hey, we also saw that at ThoughtWorks, for example. We discussed event-driven applications with a couple of people there, and we recognized that when people talk about events, they actually mean something quite different. So it's really hard to talk about event-driven like in a bigger audience because everybody thinks of different things. So I think it makes very much sense to go over that and to understand a couple of the concepts. And I structured that in a way that first I want to talk about what I called events on the inside. So how can I use event-driven to build better applications or better services? And I talk about a single service here, not like a complete set of microservices, one single service. How can I use events there in order to do things different? And then when we start to understand that, we can also talk about, hey, can we use events to communicate between services, to collaborate between services, for example, basically to communicate between them. And I call that events on the outside. That's actually pretty much in sync or also inspired by, you probably know Chris Richardson. He wrote the Microservices Patterns book in Manning, and he also talks about events on the inside and outside. I think that makes very much sense. I actually, and you probably spotted that if you read the slides here very carefully, that's topic 1, that's topic 3, so there's some topic missing here. I added something which I call events inside out. And I want to go into that like later on. I don't want to introduce that now. So that's basically the agenda, what I want to go over today. Let's go. If we look at how can we leverage events on the inside of an application or a service, I first want to have a look at how we build applications over the last probably 1 or 2 decades. Right? You probably know this kind of architecture. And by the way, that's a hint that's throughout the whole slide deck. So whenever you see that papyrus here, it means that's a traditional architecture. That's probably not the best practice architecture for the future. It's not necessarily event-driven at all. It's what we did over the last years. And you probably know that, and that's what Ted Newart once referred to as the BBC architecture. Box, arrow, cylinder. That's all diagrams you ever need, right? You can express every architecture by that. But you probably know that, right? We build an application and we use a relational database underneath. There's a great thing about that architecture, and that's very often forgotten. When we now discuss that, it's very often forgotten. The great thing about that architecture is there's a relational database management system. That's really great. It gives you a lot of features. We shouldn't forget about that. It gives you asset transactions. You probably know asset like atomic and consistent, isolated, durable, and that's awesome. You can build awesome applications by that, and really the database does a lot of things for you which are pretty hard to do. Like really care about consistency, for example, and these kind of things. So that's great. So whenever it's possible to use a relational database, I think it's still the best option to do. But the problem about that architecture is the database is not really what we nowadays very often call web scale or internet scale. So if you're an Amazon or probably even a much smaller company but offer your services worldwide, it probably doesn't deliver the scalability you need. Especially resiliency is very important. So you can either, go for an Oracle Golden Gate, or MySQL has a couple of clustering options that are not easy to set up, that are not easy to operate. So that's already hard to do. And then if you add some geographically distributed things to that, it gets really hard, okay? We have a couple of customers doing that, replicating between Europe and the US. And that adds so much latency, that adds so much problems, that this is probably not the best way to use a relational database. So that's a limit, basically, of the relational database here. If you don't hit the limit, go with the relational database. I'm a metaphor person, I'm a picture person. I remember things better if I have a picture for that. And I was in the mood of making bad animations, actually, for that slide. So I basically used Kubernetes as kind of, that's the cloud native thing at the moment. And you can imagine it like that. The relational database, it doesn't fit in Kubernetes. You can see that by the shape, right? It doesn't fit. So that's a thing you can probably remember, right? So it's not really the cloud native, the scalability architecture, right? If you look at that more seriously, you probably come across Pat Helland. I'm a big Pat Helland fan. He worked at Amazon, Salesforce, Microsoft, a couple of the big companies. And he had a talk quite a while back, actually, where he said immutability changes everything. And we have to think about immutability in order to build these resilient and scalable applications. What does that mean? And if we look at an example, and that's a very common example, actually. So let's assume you build that BBC architecture and you build an accounting application or a bank account application or something like that. You use the database, you have a table where you say, hey, this account has this balance at the moment. And that's what I call persistent state. So you persist the current state. If you withdraw money, you do an update on that state, right? That's what everybody knows here. Why does that scale so bad? Yeah, I mean, if you're now replicating the database, for example, you have one in the US, one in Europe, you have to make sure they're in sync, right? And if they're not in sync, and you do an update on the balance in Europe and an update on the balance in the US, you have a conflict, which is hard to resolve because you update it to one amount here, to another amount here. Which one wins? That's really hard to answer. So there are a couple of these reasons why this doesn't really scale. So what's the alternative? The alternative is to persist the change you want to make. Not the latest state, but the change you want to make. And that's very often known as these append-only logs, or append logs, basically, or event logs. And that works like, I just have a couple of these immutable things, like I created the bank account, then I transferred money to it, and probably I withdraw money, and so on and so forth. So I don't update the current state. I just write what we nowadays normally name events, which are immutable facts. I can never change them. And that makes things much easier. And then basically the current balance, I just derive by reading all these kind of facts, right? I can always derive that. And in this scenario, it's much easier. If I have a withdrawal in Europe and in the US, for example, and they are not in sync currently, I might make a wrong decision about the current balance and allow to withdraw too much money, but I don't have a conflict in the updates. I withdraw $100 here, 100 euros here. I'm fine, I know what to do, right? And that's much easier to scale. Like this is how you can imagine it. So this is what's very often, or what's called event sourcing, right? That's event sourcing. And that means I use the events that change as my data store for the application. And that works like this. If you imagine you have a customer service and you have your event store. By the way, an event store technically could be different things. So you could even implement that by relational database. But nowadays, you also have special applications for that. There are a couple of applications which are really focusing on being an event store. So you just store these kind of events. Then you probably want to create a customer. And now you have an execution loop inside your own service, your application, to execute that. And that works like, first of all, you have to read back all the events from the past, basically, and build some internal state of the application, because you have to know that state. In this example, you have to know if you already know the customer, right? Or in the withdrawal example, you have to know the current balance of the account and these kind of things. So you have to rebuild that state internally. The big difference is I don't store that. I can throw it away. It's just for the purpose of basically validating invariance. Can I withdraw the money? Do I have enough balance? That's the decision I have to make on that. So that's why I need the internal state. I make the validations. I decide, OK, I can create that customer, or I can withdraw the amount, and then you write the event to the log. As soon as you know, hey, that's okay, the event is getting a real fact, it's written to the log. And then you might even publish that to the outside world. We're coming back to that in a second. Like, that's an event on the outside, probably, right? So that's a typical loop you go through in event sourcing. There's one great thing about that, which is that I talked about ACID transactions at the very beginning, like consistency. There's only one requirement for an atomic operation here. Whenever you insert events in the event store, which is probably not only one, but a couple of them, this has to be atomic. Right? So you have to make sure you either write all of the events or none. But you don't need more atomicity. And I want to make the counterexample to get that across. So that's, again, the Papyrus. So that's a traditional architecture, right? So I have the customer service, and then I would go for a relational database, for example. I create the customer, and that means I insert the customer into the table in the database, right? That's my business logic. And then I commit that. That's an atomic operation again, right? I commit that. But let's assume the following. Let's assume whenever I created the customer service should also make sure an account is opened, right? So it probably want to call or want to propagate something in order to make the account being opened, okay? That's normally a remote communication here. If you're talking microservices, for example, or even serverless, it means that the customer is one box. The account is one box which lives somewhere else. So that's a remote call. If it's a remote call, we don't have ACID transactions available. We can't do a transaction which spawns that business logic in the database and, for example, sending a message on a message queue, right? Normally, some people are thinking, hey, I can do that. There's two-phase commit. There's these distributed transactions. If you're still believing that, I would recommend to read that paper. It's a very good paper, Life Beyond Distributed Transactions from Pat Helland. And I just use his own quote, grown-ups don't use distributed transactions. The summary is basically it doesn't scale, so it doesn't scale again. And the second thing is it's too complex. It doesn't really work. Nobody understands it. So don't use these distributed transactions. You don't have them. Assume you don't have them. So in this scenario, where you say, hey, but I want to have it like atomic. I want to create the customer in my database and open the account, either both or none, right? What can I do? I mean, you have to decide for an ordering of the commits. So either you commit that first, and then it might happen that the application crashes, you never open the account. Or you open the account first, and you never commit to the database. That's even worse than you have an account without a customer. So that's bad. What can you do? That's very often referred to as the so-called outbox pattern. What people start doing is they write what very often is called a job. So they write something in the database and say, hey, when I created the customer, I still have to create an account. That's a job. It's not yet done. But I write it to the same database, right? And a separate table, but the same database. And I execute that later on. And that makes it possible that I have that job creation and the real business logic in one transaction. And now it's kind of atomic because I make sure I do both, even if it's like eventual consistence that I execute the job later on. So there might be a delay, like milliseconds, seconds, probably even minutes. That depends on the application. But I make sure both will happen, right? So that's a very common pattern. I actually see that applied relatively often. There are a couple of ways of implementing that. Actually, that's not a focus for me today, but just for the reference. So either you write your own scheduler. I see that applied very often. So you write a scheduler which just regularly checks the job table and then execute these kind of jobs. I saw more often than I would have expected reading database transaction logs. So if you know that logo, that's Debezium. That's, I think, a Red Hat. No, I'm not even not sure. That's a framework for replicating databases across, very often across data centers. And what they do is they also read the database transaction log in order to replicate. So people leverage that in order to read the database transaction log to see, hey, there was a job created. We have to do something, right? That's an opportunity, possibility. Or you can leverage, that's my domain, that's my world where I work a lot. You can leverage a workflow engine in order to have a very easy workflow of doing that, right? So there are a couple of ways of doing that. So it's not impossible. Probably you even want to add idempotency, because I'm not talking about that today, but I still believe if you do distributed systems, idempotency is the number one problem you should solve very well in order to save you a lot of trouble later on. And idempotency here means I probably get the create customer message multiple times. I get retries, I get redeliveries, so I probably have that message multiple times. And I want to make sure I don't process it multiple times. So very often in that architecture, you also capture that request in a separate table. If it's a message, I might save that in my own database. I even saw that people are splitting that up into multiple transactions to make sure that the request is captured before it's executed, to make sure you don't have like the message coming again in milliseconds and being processed twice. So what I try to get across is there's quite some complexity involved to do that right. And we're doing relatively simple things here. That's a great thing if you're doing these more event source system. You don't have all these problems. The outbox pattern is basically solved because you only have that one atomic operation where you write the event, and then you basically have the same loop again. So it's kind of included in that architecture. So a couple of these problems you don't have to solve yourself. So that's, I think, one of the advantages of this using event sourcing underneath. I want to give you a more concrete example. So far it was kind of like the hello world example of event sourcing. But I found it more interesting to dive deeper, to dive into like real systems and look how they behave. And I wanted to bring you what I know best, actually. So yeah, Susanne quickly introduced me, just a couple of words. So my name is Bernd Rücker, right? I'm co-founder of Camunda. What we are doing is an open source workflow engine, right? And yeah, I always add that warning now. I'm a human being, I have my own opinion. Keep that in mind, right? I'm a workflow guy, so you probably need that in order to judge what I'm doing. But what we have, and that's actually interesting, and I discussed that a lot recently, we have two different workflow engines as open source project. The one it's called Camunda, and that's the one we have for years. And then we have a new project, a relatively new project called Sebi. Now, people are asking, why are you doing two different workflow engines, which basically do the same thing? They solve the same problem. Why, right? Why? And the reason is simple. So we have Camunda, which does persistent state. So it uses, it uses a relational database. That's how you built applications 10 years ago, right? And we have Sebi, where we changed that in order to have persistent change, in order to be more scalable, in order to be more resilient. And if you look at that, in particular, then that works like this. I'm not sure if you're familiar too much with workflow engines, but it's a relatively simple concept. So you can define these kind of flows where you say, hey, this should happen whenever I kick off a new instance, this should happen first. Whenever that's done, this should happen second, for example, and then I'm done. You can make more complicated things, but that's the basic idea, right? Activities in a sequence. If you have that in a relational database, how it works, like in a simplified slide, is like, I want to kick off a new workflow instance, so I basically insert in the right database table, right? I now have a new workflow instance which currently is in that activity, and that's it, right? And then somebody, whatever, can pick that up, does whatever needs to be done to retrieve the payment, and basically calls back the workflow engine and says, I did that, it's done. And what we basically do then is we update the current state and say, hey, okay, this workflow instance is no longer in that activity, it's now in that activity, and so on and so forth, right? Actually, to be honest, we also write a couple of database tables where we keep the changes for audit purposes. But that's kind of an additional thing. You can even configure it to not write that to save disk space or to optimize performance, for example. So that's additional. The basic thing is we update things. How does it work if you go event sourced? And that's a bit different. And actually, if we want to kick off a new workflow instance, it works like that. We write a couple of these events. The first is like we want to have a workflow instance created, right? And then basically what the workflow engine does a couple of steps in order to do that. It knows, okay, then I need the workflow instance to be created. The start event occurred because we start here. The sequence flow is taken, so because we walk that way. And an activity is activated, that's our terminology. And a task is created for the retrieve payment, right? So I have these events like written to the log. Next thing that happens is somebody says, okay, I can do that. I can retrieve payment. It logs the task. That's a detail. It's not that important. And then it completes the task. So again, we're writing that to the log. Hey, complete the task. Okay, the task is completed. The activity is completed. We leave that. The sequence flow is taken, and so on and so forth. Right? I hope you get the idea. Right? So we are just writing that. Why is that cool? Let's go into the handling loop here. And if you look in the inside of how we have built that engine, it works like that. So we have that workflow engine. We call it broker because that's kind of what you nowadays call systems if they're in a distributed system. So it's a broker. We have that event log. And let's assume I want to complete the task, that activity, right? So I send in a command. I talk about commands later on in really in-depth. I send that, right, to the broker. The broker adds it to its log, right? The next thing that happens is we store that in the event log. In our case, that's simply writing it to disk, okay? We're writing that to disk, and we're replicating it. So what we have here, we are having followers. That's a typical concept in a distributed system. Like if you use Kafka or Zookeeper or others, what it basically does, it builds an own distributed system and know, okay, I have to replicate that to a couple of peers in order to make sure it's there. I don't lose data, right? So it's replicated. As soon as it's replicated, we can process it. We don't process it before it's replicated, by the way. So I'm talking about that in a second. Then we process it. Then we need the internal state in order to do that. We are using RocksDB for that. RocksDB is a framework from Netflix. That's a key value store, a very, very efficient one, a very fast one, which can also flush to disk. So we're building that state internally in RocksDB, right? And there's one important thing here, and I'm talking about very briefly, but I think that's one of the core concepts here. And then we have one single thread which executes these kind of commands on the RocksDB. Why is that so important? If it's a single thread, we don't have contention. We don't need the isolation a relational database would give you because we don't have competing threads writing to the same data. It's one thread. It's always one thread. So we're having a clear sequence. It's totally clear what happens. It's totally it's kind of easy to understand, and it's kind of easy to build, right? So that's a very important concept. How is that scalable? I come back to that in a second, right? A single thread doesn't sound that scalable, right? Okay, come back to that in a second. But that's important, single writer. So we process that on the internal state. And then, that's also interesting, as soon as we validated that the command is executable, that we can do it, we send back a response to our client, say, yep, we completed the task. If you're really looking at it on a very detailed level, you might qualify that as kind of a lie. It's not yet executed. I mean, we haven't yet done anything, but we have validated that we can execute it. That's enough. Because now we know that we can always execute it. It's validated, it's written to the log, it has a clear sequence, it's replicated, we cannot lose the data. It's totally clear what happens. So we are kind of already have it executed. And that's why we are sending the response earlier on. We save latency, we improve performance by doing that. Right? And only if when we did that afterwards, we write all the events which occurred because of that. Like what I had on the slide earlier, like the activity is completed, the sequence flow is taken, next activity is entered, and so on and so forth. So that might be a lot of events, actually. And we do that afterwards, right? And then we append the event, and we replicate it. And the trick is that we can replay that. If something happens while appending the events or replicating it, if the system crashes, that's no problem. We can always restart it from that command, and it will produce exactly the same result. It's a single thread, it has a clear ordering, it will produce exactly the same result. So that's one of the tricks you can use in these kind of event source systems. And that's, by the way, one of the things we do different. Like, if you look at event source systems and you can, basically if you search the internet for command sourcing, that's an interesting exercise, actually. You find a lot of threads where they discuss about if that's a good idea or bad or evil even. And that's basically one of the things we do different. We explicitly store the command in order to have that faster response times, right? But that's kind of very often discussed if that's a good idea. For us, it's a good idea. So it's always like in life, trade-offs. What else do we do different? That's also interesting. We actually do persist the internal state. I talked about you don't need that. You can always replay the events. Yeah, that's true. But replaying the events take time, right? So to increase performance, we persist the internal state so we can start up faster. We even replicate that to remote peers so they don't have to rebuild the internal state because to our experiments so far, that's faster than rebuilding it. So these are optimizations. And that's also interesting. Event sourcing, by the idea, if you read about it, it's always like, hey, we have the events from the beginning of time, and we keep them for all the time. So we can always replay everything from the world. And that obviously needs a lot of memory. You have to store a lot of things. So then kicks in something called log compaction. Hey, at some point in time, we delete old events we don't need anymore. And that's the thing. It's really hard to decide which events I don't need anymore if you're a workflow engine. Because some workflows, they run for months. So you can't just delete old events. They're probably still very valid. So for us, that was a really hard challenge to compact the log, because then you're going through a whole log and delete, for this process instance, this workflow instance ended a month ago, so we can probably delete it, but the events are here, there, and there, and there. And we try to be fast and efficient, so we even optimize for disk writing performance. So that's not a good option. Then you're ending up with a fragmented log. So what we do is, as soon as a workflow instance, as soon as a command is completely executed, as soon as we don't need it anymore, we delete it from the log. Right. So as you can see there, we're not purely event sourced. I want to quickly at that point, talk about CUP. You probably know the CUP theorem, right? See some people nodding. Are you still listening? Yeah? Okay, awesome. Some people are nodding, yeah. Right, the CUP theorem. And I love that thought experiment about the CUP theorem. That's how I can always remember it. So the CUP theorem says there's consistency, there's availability, and partition. You can only have two of them. And basically, you can't decide for partitioning. If you have a distributed system, you can always have partitions. And the analogy, the thought experiment, is marriage. So marriage is an atomic operation, right? Either both are married or none of them. We do that in a very monolithic way. We meet at a church, everybody. Every resource is blocked until we're done, right? So it's a very inefficient thing to do that. But we can make sure we're consistent, right? If you transport that to a distributed system, we want to be more efficient in marrying, then we can do it via the phone, right? Remote. And then you can think about it. The priest asks, do you want to marry her? I say, yes. And then, do you want to marry her? And the line breaks. You don't know the answer, right? You don't know what happened. I could be married, I couldn't. I don't know. And then you have two options, right? The first option is okay, I don't know. And just in case I date this evening, right? I want to be available. I mean, otherwise I'm not married and then I miss that date. That's kind of a waste. So I go for dating. Then I go for availability, right? Or I could say, no, I don't know, so I have to wait until I know. I don't date. No. Probably I'm married. And that's consistency, right? And you have to make that choice. You have to make that choice very consciously. And for example, in CB, we definitely decided for consistency. So if we can't, and these are details in this event source system, if we can't replicate, we're not executing, right? So we go for consistency. In the account withdrawal example, for the example, you can decide if you have a partition, if Europe and US is not connected, you can decide if you want to withdraw the money, go for availability, or if you want to wait, go for consistency and to not give the people too much money, right? So that's a decision you always have to make in these kind of systems. So how do we scale? I have a single thread. Single thread is not that scalable, right? We do partitioning. So you have that single thread, but then we have multiple partitions. Each partition has a thread. You can distribute them on one machine with multi-threads, or you can even distribute them remotely. And then for every single workflow instance, we are sure on which partition is executed. And then for every workflow instance, we have a single write. This is how you scale these systems. Okay? Good. That's event sourcing. If I have an event source system, the next problem I have, I can't ask the event log questions like, which workflow instances do I have? Where do they currently wait? Are they taking too long? And these kind of questions, you can't ask that in event log. So what you need is to have to build in another, like a separate read model, a query model, which you can ask questions. In our case, that's Elastic. So we push out all the events to Elastic, build our own read model, and this we can ask with like our tooling, for example, in order to show the operations, what's going on. And you have to think about that. So as a summary for events on the inside, I think it's a good way of building like really resilient and highly scalable systems. That's awesome, right? But you have to think about a lot of things. And my experience so far is that and this is, I think, the important point, there's not that much industry experience available. So probably there's not that many people that understand it. Probably most of them are here at QCon, and if you go to other conferences, like typical developer conferences, rarely nobody understands this, right? So it's really hard. And I would really think about if I want to go that way. Go there only if you really need it. Okay. There is something, if you go more on the outside, I call that inside out. So what's that? If you think of our system where we have that event store and we have a service, right? Normally, if you are event-driven, very often you also use messaging. I rarely see that you have a REST API for that, but it's probably also the case. But let's assume you have messaging. So one idea which is probably not that surprising is to say, hey, I had that event store down there, I have the messaging down there. Why shouldn't I merge them two? That's probably a good idea. And then you have like a shared event store where you say, hey, you don't send me the event via message and I write it in my log, write it in my log yourself. Right? It sounds a bit weird, but it's actually advertised relatively good. So if you look for Kafka, for example, and these like messaging as a single source of truth, it's not explicitly written, but it sounds like this is what you should probably do. I personally, I'm not that convinced that this is a good idea, so I always make that exclamation mark there as a warning, because now you open up your internals. So I'm a big fan of having my local data of the service, which I can totally control, and having a clear API, right? So I'm actually not a big fan of that, so I personally wouldn't go that direction. What you can do, but I think it's important to make the distinction here, is you can use something like Kafka as kind of like, let's say, the input topic, the input queue. So you can use it as a transport. That's fine. And it's still persistent, by the way. That changes a lot of things. It's not like in RabbitMQ, you consume a message, it's gone. You have consumed it. In Kafka, it's persistent. That changes a couple of things, how you can work with that. That would be a good place also to talk about streaming, but I don't have the time, actually, so I don't do that today. So if you're interested in discussing about streaming architectures, probably approach me later on. Awesome. So that's event inside out, very short here. I want to dedicate the rest of the time basically to the outside. So how can I use events to communicate between services? And that's actually what probably much more of you will do on a daily basis. So again, let's say 20 years back. We have a CRM system and we have other systems, right? Whenever you change the address of the customer, you have to inform all the other systems, right? That was the big time of enterprise application integration tools, or probably even ESBs, right? How do I make that efficient, that the customer change the address in the billing system? With event notification, you turn that around. What you basically do is you say, hey, the customer, the CRM system, that's a very general component in my whole architecture. So that should produce events, put it on some topic, don't know about who is interested in that, and the billing system knows, oh, I should listen for address changes, and consumes it, right? The direction of dependencies now, the billing system knows about address changes from the customer, and not the other way around, like the customer service knows about billing and has to inform it, because then you end up with the customer CRM system knowing basically each and every system. Okay, that's the idea of event notification. There's one interesting discussion, which I don't want to go into details today, but just as a reference. Whenever you do that, you will end up with discussions, what's the payload of my event? Right? In this case, a pure event notification, if you go for terminology, would be the address has changed. Now it's your problem. And that basically means I probably have to ask for, okay, what's the new address? I want to have that. I need that, right? So much more often, actually, I see something which is, if you go for terminology, it should be event carried state transfer, right? So I'm not only saying, hey, that has changed, but I add the data. But that's a discussion in itself. So that's a whole own talk. What data should I include in there? It could be like this. I could send a delta. That was the old address. That was the new address, right? I could send just the, hey, the address has changed. That's the new situation. That's the new state. That would be an option. I could even discuss about granularity. Is address changed, or do I send a customer change whenever something changes in the customer? Or especially in domain-driven design, if you go to these communities, they normally discuss it in a way that, yeah, address change, that's kind of a technical thing. Why should I care about address change? I care about the business requirement behind that, so the customer has moved, right? That's a different event. Yeah, I spare that discussion today. It's very interesting, and to be honest, it's very hard to get that right. Because as soon as you have these events defined and circulating around, it's pretty hard to change them, right? So. But I don't have to talk about that today, so I move on. It's complex, it's not easy. The other one, and I want to actually dive into that in more depth. There I also have much more experience, so I can talk into more depth about that. And that's the decision if you want to call somebody else, right? Or if you want to be notified by an event, right? And that's actually also a very complex decision. And done very, we don't yet have a lot of understanding how to do that right. And if I go in the details, I'll make an example. Let's say you want to change the address. You go to a web interface, say, hey, I want to change my address. And let's assume you get a notification email which says, hey, your address is changed, is that correct? Please confirm that, right? Couldn't imagine that very much. Okay. So if we do that, if we implement that, we might end up with 2 different services, the one for the CRM, the customer management, and one for sending the notifications. Now we have 2 possibilities. The first is, hey, please change the address. So the customer service, it publishes an event like address changed. Not yet, it needs to be confirmed. So it's more like address change requested. Notification service knows, oh, if there's an address change requested, I send out an email, wait for the notification. When it's notified, I can basically say address change, or address changed, or address change confirmed, something like that, okay? In this case, I have the direction of dependency from notification to customer. Notification needs to know about customer, right? The alternative, the other way, is the other way around. The customer doesn't send an event, but it knows, hey, there's a notification service somewhere. I can leverage that. I send him a command to send an email. I wait for the response, and then this probably sends back an event, like, hey, the confirmation was approved, and then I probably generate the address change event, right? See the difference? In this case, I have the direction of dependency from customer to notification. And the thing is, that's a case-by-case decision. There's not a single rule where I say, go always event-driven, and that's actually what I see a lot in the current projects. They think of, hey, event-driven, that's the future. We want to be the future, so we go event-driven. But it's not that easy. You should always think about, do I have event notifications, or do I want to send commands? So that's quite a challenge. There's one thing, and it's basically only about terminology, but I think it's really important. So if you look at that, what makes that even more important is that people mix it up very often with, for example, with communication protocols. They think if I command somebody, like, change the address, hey, that's REST RPC, I want to do that. I want to be like event-driven. But that's not true. It both can be messaging. You can put a command in a message, send it over, no problem, right? It can be REST, even if it's event-driven, like REST feeds, for example, is an example, to be event-driven with REST technology. So it's totally independent of the question of what kind of transport I want to use, right? And especially nowadays, you have a lot of technical possibilities to be event-driven, for example. It might be Kafka, that's what everybody's thinking. Oh, event-driven, I use Kafka. But it might also be a topic on Rabbit. It might be REST feeds. It might be webhooks. Webhooks is event-driven, right? Especially if you look into the whole serverless or cloud environments, they have a lot of ways of being event-driven, right? Basically, everything is event-driven there. That's, by the way, one of the reasons why I think will get more and more important over the next years. Right? So that's all event-driven. It's not only something like Kafka. But the problem then is, like, if we have that event, and an event is always a fact, something that already happened in the past, immutable. We have the commands. The command is an intent. I want somebody else to do something. Some people then discuss, yeah, but that I want somebody to do something is already like a fact, like an event I want, but that's kind of a weird discussion sometimes. But I have commands, and sometimes I want to know something from somebody else, so I have queries. And that's actually very much agreed on. Even if you read through CQRS communities and these kind of things, we have event, command, and queries, right? That makes sense. It's even in the Enterprise Integration Patterns book, I think it talks about events, commands, and queries. So that's the thing. But the problem now is, like a couple of years back, normally that was called a message, right? Because we had messaging systems. Sometimes nowadays, if you use Kafka, they talk about record. Okay, I can live with record. But a lot of people refer to that, like to, let's say, the common class of that, to be an event. And that's actually a clash we currently have in a lot of discussions, is that people are, when they say event, they either mean the content, the event, the fact, or they mean like I'm sending a message. And that can lead to very weird discussions. So that's why I'm really putting a lot of emphasis on that. It's only terminology, but I think it's important. So personally, I try to really talk about messages or records. In CB, for example, we called it record as well, not event, right? Because that's a clash. So then you have events, commands, and queries. What I see a lot as a result of that are what I call commands in disguise. So, hey, the customer needs to be sent a message to confirm the address change. Hint, hint. That's a command. I want somebody else to do something. If that helps you in order to get your architecture through, might be okay to do it. But one thing which is very important from an architecture point of view is that the alternative, like send a message, normally uses the terminology, the wording of the recipient, so the service which provides that service, which is more natural, which normally is a much more stable API, versus the command in disguise uses the words of the sender who wants to do something, which is normally not that stable, right? Okay, let's do a couple of examples to make that more concrete. So let's assume you have a payment service. Then for me, it's very natural that other services who want to retrieve payments sends a command, because otherwise the payment service needs to know all the services which probably need a payment. That does make a lot of sense, right? So in this case, I want to have it in this direction. Let's assume, the address change, we already talked about that. For me, that's a very good example where I want to have it in this direction, because the customer service should know about all the clients which are interested in address changes. If you go for a notification service, which probably does all the notifications for an order fulfillment, it could be completely event-driven because it knows about what stages the order could be in order to send the right notification. So that event-driven makes a lot of sense for me. But it could be different if you have a general notification service which sends out notifications for everything in your company. That's very weird that this should know about orders. Then you have to send a command. So it's really a case by decision. So that's just a couple of examples to get you into the thinking. When I discussed the talk with Susanne, when I prepared it, actually, she had a good example as well. I like that. So they had a kind of a document management system. That was the context. And they used DDD, and they had a couple of contexts, like for caring about the document, for caring about a certain page, and probably certain attachment, and so on and so forth. And they had an authentication service. And they started with an event-driven approach where there were a lot of events, like whatever document has created, a new page is added, or whatever, where you have to add authentication information. And if you do this kind of thing, you end up with every change in each and every single bounded context lead to normally a change in the authentication service. That's what we call a distributed monolith. You can't independently change anything anymore. That's a pretty bad situation to be in. So in this case, it got pretty clear, and they refactored it to have a clear, stable API, basically. And the services down there, the bounded context, basically call the authentication service to do something, right? Okay. Enough of the examples. Next challenge, 5 minutes for that. That's a challenge as well. Event change, one of my favorite topics. Let's assume you want to create a customer, and let's assume you do a couple of checks before you do that. These are a couple of services you have for that and an event bus. It could work like that. The registration says, there's a registration requested. That's an event. Credit check says, okay, then I have to check. The customer, oh, I did that. Then address check knows, oh, if the credit was checked, I need to check or verify the address. If that is done, the customer can be created and it's registered, right? That's an event chain. That's actually how we can implement these kind of flows. If you do that, it's pretty hard to get an overview how that works, right? So I personally, it's hard to understand the system. It's, yeah, it's just during runtime you see what's happening. I personally love the blog post from Martin Fowler. He said the danger is that it's very easy to make nicely decoupled systems without realizing that you're losing sight of a larger scale flow, and thus set yourself up for trouble in future years, right? So that's a danger you have with these kind of systems. I skip that for a second. Hang on. If we want to change it, let's assume we get it somehow, right? We can work with that, but we want to change it. And let's assume, and that was, by the way, that's a real example from a customer I discussed that with. They wanted to add an additional check. Let's assume something like criminal register check. If you want to do that and you want to add it, you have to change a couple of things in that system. The first is you have to remove that notification, and now you have to listen for the address checked in the criminal check. And then you have to change the customer, not longer to listen to the address check, but to the criminal check, right? So you have to have two changes which you have to coordinate. Not a good idea in a microservice environment. Not really decoupling, right? Now you could argue that this is a bad event flow. It's not a good event flow. And I do agree, probably we should do it differently. So let's try again from scratch. You can't do that often in the real life projects, but let's do it for now. Registration requested, both address check and credit check listen to that. So it's a parallel now, it's changing a bit, but it gets easier. Now they produce their results, customer aggregates that, does everything. Now we can just simply add the criminal check without changing anything else. That's good, right? But you still have to change the customer service to basically incorporate the result in order to do something. So you still have two changes in your microservices. And I think that's my point here. I think that's unavoidable. You have these two changes. You want to have these two changes. You want to change your system, right? The thing is, how easy is it to do that? And if you now have requirements for the sequence of these kind of things, what you want to do there, that gets pretty hard to do, right? So if you want to change something, it's like in this game, if you say, hey, we want to keep it stable, don't worry, we don't have to touch it. You just have to remove that stick down there. That shouldn't be that hard, right? That's it. That's all we ask, right? And that's how it feels. That's what I see in a lot of systems currently. Yeah, I always use that picture. Like, this is a choreography, right? That's these event ping pong we just saw, a beautiful dance. We add a new microservice, and it's part of the dance. It's not what I see in real systems. Right. So, right. What's the alternative? And that's basically one of the last things I want to talk about. It's orchestration. Orchestration means that in this case, I want to have it registered. Now, the credit check or address check doesn't listen to that. We have a separate service that might be merged with the customer service. So I did it as a separate service, but it can be the customer service. That depends on different things, right? So this listens to it, and then it sends out commands. It says, hey, the credit check, please do that for me, and wait for the response. As soon as it did that, hey, address check, please do that for me, wait for the response. And then it says, okay, now we're done, right? And now you have that one point where it can change, where you can remove the stick easily, right? And that's important to keep in mind, and that's very often connected to the thought that you need these kind of commands. It's not everything is event-driven. Good. If we look at the change scenario, that gets easier again. Like, we have these address checks. We want to have the criminal check additionally. What do we have to change? Yeah, we have to change the customer onboarding, right? Because this one now knows, okay, we have to have that additional. And if you compare that, and I wrote an InfoWorld article, which is linked here, which compares the changes, the coupling you have to make. From my perspective, it's exactly the same. Like, you have to change the customer service, you have to change the criminal, or add the criminal check service, right? In both scenarios. So why do I emphasize on that? Because I think it's nonsense that purely choreographed systems are less coupled than the others. If I have a communication between two things, it's coupling. It's not, you can't avoid that. You can't decide about how to do that. Yeah, and in my world, you can do orchestration with workflow engines, obviously, but you don't have to. Skip that. Skip that. So, commands and events decide about the direction of the dependency. That's a very important thought, actually. And as soon as you have that, and beware of event chains, you lose sight, and you don't have less coupling. That's simply not true, right? So you should balance choreography and orchestration in a way that it makes sense for your architecture. It's not easy, but it's very important. Right, so that was basically it. I walked through the events on the inside, the event sourcing part. I went through shared event stores and the events versus command. So there was quite a lot of things, actually. I hope that got across at least a couple of the ideas. If there are any questions, I think we don't have time now. So I'm still available here. We have a booth over there. Approach me there. I do the summary if I will. I put a lot of effort in the animation, actually, right? So it's not easy, right? Events on the inside, it's even harder, but it's doable. I mean, you can do that, and it's probably worth it if you need it, right? So I needed to do that slide. Sorry for that. Thank you very much.